everybody. I want to welcome you all to our new YouTube channel, Learn Networks. I would like to present ourselves since this is the first video. So we are a team of network engineers and we work for a large service provider company. We have different experience areas. Some have experience in data, some have in collaboration, wireless data center, security. And there is no sequence here. We are focused on our day-to-day challenges. So we are used to provide complex designs for most customers that have different requirements. So we are not going to present you how does HSRP work. We assume you already know that. We are going to take these protocols and technologies and mix them to give you a solution. Another brief overview. I want to present myself. My name is Marcelo. I am an engineer. I have a master's degree in computer engineering as well. I have 15 years of network experience, so I've seen lots of weird things, and I have some Cisco certifications. This video over here, we are talking about branch office manipulation, path manipulation. So we're going to talk a little bit about redundancy when you have dual MPLS WAN connections, the types of load and the benefits. Then we are going to the lab. I created a lab in GNS3. Then we're going to discuss a little bit and conclude, and also some references. For the lab, if you see the description down below, you will see the link where you can download the initial configurations of the equipment for the lab. So what are we dealing here? You are a network engineer and you are responsible for the branches. So we are going to deploy new branches and you are going to maintain these branches working. And there are some branches that are quite large and they require dual circuits for redundancy, for high availability. And probably you have the circuits in active and standby fashion. The thing is that MPLS circuits are very expensive and we want to use whatever we are paying for. So ideally, we would like to use both circuits. We are not going to channel the circuits and have, let's say you have one 10 meg and one 5 meg circuit. You are not going to bundle it and have 15 meg circuits. However, you want to do some kind of load sharing where you can use the 10 meg and the 5 meg at the same time. However, you don't have access to the core. Probably you can make some tweaks on the branch routers, however, you are not allowed to touch the core. So we're going to see how we can manipulate BGP to influence the traffic from the core to the branches without touching the core. So this is our branch topology. This is very regular. So you have eBGP running from your border routers to the cloud. You have your layer 3 core switch that concentrate the gateways for your VLANs such as users, voice, security, servers. And you are willing to load share these circuits. You want to have the first two VLANs traffic from the core using router 1 and the other two VLANs coming from router 2. This is a very good approach. So we have a boundary here. From router 1, you have two routing protocols. You're going to have eBGP for the WAN and a IGP, in our case it's EIGRP in your LAN environment. So the EIGRP portion is going to deal with the upstream traffic. So traffic that's coming from the branch to the core. And BGP is going to handle the traffic from the core down to your branch. So our challenge here is to manipulate the traffic that comes from the core, from this loopback 10.1.1.1. So I want 10.1.1.1 to reach VLAN 201 and I want this to take this path. And for VLAN 203 and 204 it's going to take this path. And if a circuit failures, it's going to rely on router 5 and vice versa. So let's take a quick look at the routing table with no configurations at all. We're just advertising our networks to both MPLS routers. In your core, it is going to see something like this. You're going to have a tie. For network 201, you're going to have two paths, and they are going to be tied. And unfortunately, we have to break the ties with some rules. And most of the times you are going to fall into the rule that is the oldest route wins. Oh my god, so let's say you have a 10 meg here and a 5 meg on the secondary one. So if the primary circuit fails, the core is going to rely on this other path. It's going to rely on the secondary path, on the 5 megs. When the 10 meg comes back, it is not turning over to the 10 meg. It's going to still using the 5 meg, and this is going to be a nightmare for you. You are going to have to go to your core secondary router. You have to shut down BGP, wait it for it to converge, and bring it up again. This is not good, folks. So let's take a look at it right now. Here we have the GNS3 lab topology. So it is basically what I've shown you in the PowerPoint. This is our networks. This is the loopback interfaces. I told you the interface 00 comes to this MPLS2, and the 1011 0/1 comes to the primary. And if we see here the BGP routing table for VLAN 201, you see it's a tie, and it is relying on the circuit that has been up for the longest. So I'm going to shut down the circuit here on branch 1 to simulate a failure, and we're going to see it's going to remove this path, and it's going to rely only the path for 1010. So I'm going to pause here because BGP takes a little while to converge. Okay, so here we have it. Now that branch router 1 is down, we can see that the core router is only seeing one path to each of the VLANs, that is on the 1010, which is on MPLS2. And we can still reach it. I hope. Yes, we can. And once the circuit comes back, we are going to have the path restored. However, it is going to be still tied on the MPLS2 traffic. So this is because it is the oldest route. Oh, here it is. So for this VLAN we are going to 1010. Okay? It is not coming back to 1011. So let's add something that can untie this path decision. So when it comes back, it can compare and make a smarter decision. So what's the idea here? We want core, the core switch, the core router. We want it to use MPLS 1 to reach VLAN 201 and 202, and we want it to use MPLS 2 to reach 203 and 204. So, but we cannot touch the core. We are going to create a prefix list matching the VLANs, the prefix VLANs that we want to add prepend. So these networks here, they are not going to use the circuit because they have a prepend. They're going to have a worse route. And don't forget to create the route map with a permit statement, so all the other routes are going to be advertised. Otherwise, we are only going to advertise the prepended network and nothing else. On the R5, on the secondary circuit side, we are going to match VLAN 1 and 2, and we are going to add prepend. So basically what we're saying is don't use the circuit for these prefixes, which are the VLAN 2.1 and 2.2. Then we are going to advertise it on our neighbor relationships. So let's jump into it. We can see we don't have those right now. Okay, yeah, we don't have it. However, I have already created the prefix lists here. All right, we have the BGP prefix list matching the VLAN 203 and 204, and we are adding this AS prepend on this prefixes. I always like to select the name and paste it just to avoid little mistakes in the outbound. Ooh. Really? Oops. There you go, guys. We're always doing this kind of things. The same thing for branch router 2. Let's check the route map. I think I did it wrong here, right? Yeah, I did it wrong. I'm a little nervous. This is our first video, so I'm sorry. iOS could say there is no such route map. Anyway, the name of the route map is BGP out, which makes sense. And you can see that we have the BGP out also in here. And if you are thinking, oh, okay, this is the traffic coming from the core to our branch. Now, what is the path it is going to take from the core switch up to the core? Well, let's take a look at it. I created a route map that is redistributing BGP into the core switch on both routers. So both are advertising only their loopbacks and the default route. So in the core you see a dual default route. So to reach 10.1.1.1, it is going to load share the EIGRP fashion. You see, it's going to take both. sometimes we don't want that. We want things to be symmetrical. So I added a plus for you guys here. I added a policy-based routing so we can match the source networks, and it's going to send it to the right router. So it will be already on our configurations. You see basically here I have a route map PBR, which is going to match the network. Here is only the host, but you could match the whole network, and you are going to send it to the correct exit gateway that you want it to go. In this case, I added the verify availability because if it's not available, you want it to fall back to the default routing table. I'm also tracking the link state of this interface, because let's say the WAN circuit is down, your interface is still going to be up. It is going to forward to router 1. However, router 1 is going to forward back to router 2, so there is no problem. It is only going to remove this statement if the interface goes down, so the router is dead. So let's see what we can see now. And also, just to have it clear, you see we are taking the same path. We are going to 1010 for all of our networks. All of our VLANs is going to 1010. Now, okay, so now that we have our route maps correctly applied to the BGP neighbors, because for some reason I did not do that because I'm so nervous here. And we can see, yeah, both configurations look good. Now in the core, there we have it. There we have it. Okay, so for 201, we're going to take the 11 path, which is this one. And for the secondary one, for the VLAN 203 and 204, we are taking MPLS2. Awesome! Let's check it. Which let's trace it to see if it's the right path. Yes, it is going to the first one. Let's check. Okay, it is the same, which was expected. Now we see it is taking another path. This is going to the secondary MPLS. Well, this is great. Now we have some load sharing. We can check it from the branches as well. This is going to rely on PFR now, okay? We can see it is taking the link of branch 1, which is this 10.100.0.1, and on network 2. It is going to the secondary circuit. It is symmetrical. So let's see what happens if a circuit goes down. Let's drop BGP. And this is really great, guys, because when a circuit's down, what you're going to see in your BGP routing table, you're clearly going to see the AS path prepended here. Well, now router 1 is down, so the only path it has is to MPLS2, and we can see it is taking MPLS2, but you see this AS prepend here on these two networks. So it is very easy to see that we have a circuit down in this branch office. And now it is the truth. Let's bring it back and see if the load sharing comes back alive. Let's hope. Oh my god, it is fast. I don't believe I'm saying this, but BGP in this case was really fast. And we can see it automatically came back load sharing the way we intended. So we are relying on the lowest bandwidth circuits for a while. When the circuit came back, it is back online the way we designed it. And we didn't have to touch the core at all. What is the conclusion we have here? Load sharing is going to bring design value with simple implementation and maintenance. You can see once you are used to it, it is very easy to manipulate the prefix lists, and BGP is going to advertise it the way you expect. You just have to be patient because BGP is kind of slow. Your customer, your managers is going to have a great experience. You are going to use more of their money. It is going to bring value. So maximizing the circuit utilization, you use what you pay for. And there is no manipulation, no intervention at the core, only at the branch side. So don't need to worry with the core team, which is going to be yelling at you. So I want to thank you guys. This is our first video. I hope you enjoyed it. There are some references here. I think I'm going to copy and paste on the description down below. And let's wait for the next video. And I hope you guys enjoy it and leave your comments.